So this is the first code we make, and it's A star code search, and it's the graph where we connect the dot between one point to the other. And this is the strike line for Bucharest, where we can know that Arad to Bucharest in a strike line is 366, and Zerin to Bucharest in a strike line is 374, and so on. And this is the code where we will make the code where it's gonna be the path we choose. Here is the code where when the vertex is the destination, where it's the destination, then we will know their the heuristic, cost, and path. And this is the we call it iteration, where we will compare one vertex between the other for the destination in the end. Here is the current cost, where it's cost plus grab vertex next code, where that means it is the cost for now and the cost the other. The it's the cost for before, and this is the cost for between before and now that we choose. And heuristic is where we compare, we know that A star is a comparison between real cost plus track line, and this is where we will compare one line and the other, one vertex and the other. This is where we will enter the start, and this is where we enter the goal, the end vertex. If there is no vertex that we enter in the graph, then it will be error. If not, then we will do the code in the part I mentioned before, and in the end we will know that the heuristic of the path and the real path curve of the cat of the path, and the city we will visit until the end of the vertex. That's it. So this is the second code, GBFS, or we can call it greedy base for search, where we will later just compare the strike line for its city. This is the graph, and this is the strike line. This is the code where if the vertex is our goal, then they will show us the heuristic, cost, and path. Where the path is the city we visited, and the cost here is the cost for one city to another, and we will plus them and we will get the path cost, the total path cost. And the heuristic here is the strike line. Here for the next code, how we will choose? We will choose from the strike line, and the current cost is where we will know what is the total path cost later. Here is where we will enter the city we are from and the goal of the city where we will choose as the end of the vertex. If there is no city with the name you input, then you will get an error. And if the start and goal you input is there, then we will go to the code and we will get the heuristic, path cost, and optimal path for GBFS, where the optimal path is using the strike line of that city to the goal. This is DFS, or we call it depth first search, and this is the graph like we know before. And in this code we didn't use the strike line, so we will skip over the strike line. And this is the coding where if there is still no path, then the path is the start of the city, and if the vertex we are currently on is the destination or the goal, then we will we will we will give out the path from the start to the goal. And this is the code for like before, where we enter the the start of the city and the goal and the city of the city. And if there is no city we input there, we will give out error. And if the goal and the start of the city is inputted correctly in there, then get we will use the code to search for the path. That's it. And DFS is where the path cost is not the lowest, but the path is the lowest. So if right, like if we have to go through 5 city to the goal with lower path cost, then we go through 4 city to the goal, then DFS will choose the 4 city even if the path cost is greater than the 5 city. Okay. This is the uniform. This is the graph where like before, and this is the coding where we will decide on the path we go through. If the vertex is the destination, then we will know the cost and the path we have been through. And for the next node, we will know the cost and the next graph. We will choose from the from the from the smallest path, smallest cost path, where if there is two next vertex with different path with different costs, we will choose the smallest cost with the mind that the next path will be small too until the goal. And this is where we enter the start of the city and the goal of the city. If there is no such city in the source or goal, then we will get an error. Or if there is a goal and a start, then we will go through the code where we will get the path and the path cost. This is the fifth code, IDS, iterative deepening search, and this is trace list where it's starting from 1 because our initial position is harat, and this is the decoding. It is from the edge at edge where we will connect one dot from one dot, one city to one city. And this is the code for where the recursion is stopped when we have reached the maximum depth. And then this is the recursion for all the vertices adjacent to this vertex. This is how we put all the visited nodes into a list. And this is how we repeat depth limit search until the maximum depth. And here is just just to ensure that all numbers have been appended properly. This is the city names, and this is at edge where we will add, not add, but we will connect one city to the other. And after we connect them, we will then go back into the code where we will go through the code to do the iteration deepening search. That's it. This is the last of our discussion for today. It's BFS best kok best apa
Bre.
bread bread for search, and it is gonna be here. You see from collection import, this is gonna be our grab, but it's it's gonna be import from here. And then this is, if our start is the goal, then the path is start, there is no path, and the visited is just start. That's it. And the neighbor, if the neighbor is the goal, then the path plus the current and the neighbor is the path. If neighbor invisited, then we will continue until we got the end of the path. And here's the graph. And then here is where we're gonna print the path of our graph, where we are gonna go from Arad to Bucharest. There is no input here, so it's decided from before that we will go from Arad to Bucharest. Then we're gonna know the path from the code, and that's it.
Ri.